Hello, hi everyone. Hope you're having a great evening. So today we have with us Buddhadev Goswami, and he's pursuing his PhD from IIT Bombay. He has also done his MTech in biomedical engineering from IIT Bombay as well. After he has done his BSc in biotechnology. So I believe it will be a great learning session. Thank you so much, Buddhadev, for coming to this session. And I hope it's going to be really educational, helpful for both the parties. Thank you.
Uh, yeah, thank you for the nice introduction. I'm sharing my screen. Uh, wait, wait a second. I'm not sure some issues. Is my screen visible to all of you? Is my screen
Yes, it's
Yes.
visible to?
visible.
Yeah.
Yes, it's visible.
So, hi, I'm Buddhadev Goswami. So, I'm a research scholar at Koita Center for Digital Health, IIT Bombay, and I'm doing currently doing my PhD, and my PhD supervisor Professor Ravindra Gudi and Professor Nirmal Punjabi. So, so today's talk is about transforming healthcare with AI and machine learning and innovation in digital health. Um, so before starting the talk, I want to tell something about myself. So I am a biologist turned engineer. So I started as a biologist and now I am literally turning myself into engineer. Still in the process of doing it. So I did my BSc microbiology from Bardhaman University, where I learned about how this wonderful world of biology, how small microbes actually contribute so much to our world. Then I did MSc from biotechnology from Bardhaman University, and here I worked on bioinformatics and especially gene mutations in hematological diseases like thalassemia. And then after a little bit of gap in my career, I came to IIT Bombay to do my MTech in biomedical engineering, where I worked in the proteomics lab IIT Bombay, where my project was about doing post translational modification in malaria, in Vivax malaria, using mass spectrometry. And now I am changing my career once again to the computer vision field and doing my PhD in digital health from Koita Center for Digital Health. So, so my agenda will be first the three agendas that are I want to cover in this talk. That is why digital health, and what are my research overview. I want to go through the research overview, and as I know that most of the people here will supposed to be from the biological background, I want to cover a small part, the how you can start a AI career in as a biologist. So first of all, I want to say what is digital health is. We may know that like these are the definitions from the World Health Organization, that it is a digitization to improve the health, the field of knowledge and practice associated with developing the use of digital technologies to improve health. So from the name itself, we can understand that digital health means digitization of healthcare. But the reason things comes of why we need digital health. Um, so this is a picture of a normal public hospital. You can go to any public hospital, what we call a government hospital, and you can see this picture every day. That 200 or 250 people standing up in the queues for OPDs, and same goes for the indoor patients also. That thousands of people are lining up and doesn't getting bed for admissions. So, digital health, when we are talking about digital health, so these people can be benefited from the digital health. I will explain how. So digital health actually help in data management. So these people actually generate lot of data that can be used for betterment of the public itself. And we can use it for the telemedicine. So telemedicine where you don't need to come to such queues and stand in the queues and come to the hospital, and early detection or uh, early intervention for prognosis can be done. Then you can monitor the health where a chronic condition like type 1 diabetes or acute kidney disorders, chronic kidney disorders, we can do health monitoring with the help of digital platforms. And also the health awareness, which is mental health or physical health both, which are very much important in today's world. We can do awareness through different apps or platforms that actually contribute, and these all are part of digital health. So I will give you some examples why this burden, these people who are 250 people standing in a queue, are actually causing problem for the clinical physicians and themselves itself. So this is an example where suppose you are in a government hospital setup where a radiologist who has hardly get 5 minutes to do an whole abdomen ultrasonography. So lot of people lining up for ultrasonography in the morning, and he hardly gets 5 minutes to do complete it. So this is a USG image of a kidney cyst. You can see a vacuole in near the kidney, and this is a adrenal adenoma. This is also a vacuole in the kidney cyst. Both looks very similar, and both, but one is not so serious. It is not a fatal one, but another one could be adrenal adenoma. Actually means tumor, and tumor, as you know, can turn into cancer. So both are similar kind of looking for a radiologist, but both have different diagnosis. So it takes time to understand for the radiologist to differentiate between both, which is a cyst and which is adenoma. If it doesn't give enough time to understand this, which one is what, then it could be lead to a misdiagnosis. For that, you need something called a color Doppler or a contrast enhanced USG, but this need at least 15 to 20 minutes time, which the radiologist doesn't have. So this can lead to a misdiagnosis, and this can claim lives, which nobody, not the patient or the radiologist, has any errors. So can we use something like AI or digital health interventions to detect these kind of problems? That I will come to my later slides. So giving so this is the first example where I showed why this burden on healthcare is a problem. But second comes to an personal experience that I experienced a few months back. That I went to a hospital in Mumbai. Mumbai, as you know, is a big city where the hospitals are well equipped, but the treatment took me 3 hours, but discharge procedures actually took me 5 hours to complete. So, because everything is on papers and nothing is digitized, the doctor has to write everything in a Word file, and he has to sign it. And this whole process of charging and billing and everything took 5 hours to complete. So, this is a very much hassle for the patient also and to the doctors also, and both the parties are very much mentally stressed for this. So why this reason? What is the reason? Because there is a lack of digitization and electronic health records in this. Electronic health record, I will come to the next slide. What is a electronic health record? So electronic health record is that a system where all of your medical records will be kept in a software based in a software that takes all the data, including your prescriptions, your image data, your radiological data, your pathological data. Every data will be kept in electronic health records. And to solve this problem, India came with a mission which is called Ayushman Bharat Digital Health Mission. So Ayushman Bharat Digital Health Mission is hello. Um, am I visible or something? I got disconnected. Hello. Hello. I just stop sharing my slide. I can share it. with you.
Yeah, you're audible.
Um, is my slide visible right now?
Yes, yes, it's
Hello.
visible.
I'm not able to. Wait a second. Just a second. Just a second. Let me correct it. Somehow. Um, there has been some issues with the tunnel microphone. Uh, Microphone. Yeah. And um. Yeah. Is my slide visible right now? Hello. Is my
Yeah,
slide?
it's visible, but
Yeah. But
it's not.
I'm not able to hear you clearly, so I don't know how to answer the questions. Wait a second. I'm just rejoining 1 second. Am I audible right now?
Yes, you are.
Yeah. Okay. Okay. I'm sorry for the inconvenience.
It's totally fine. Just take your time.
Yeah. Yeah. So I was continuing with the Ayushman Bharat Digital Health Mission. So Ayushman Bharat Digital Health Mission is something that has a unified interface that can aggregate all your healthcare data into one. So it will help both the regulators, the insurance companies, the hospital, the clinics, the clinicians, uh, the state government, central government, all the beneficiaries for this. So once Ayushman Bharat digital health mission is fully functional, it will generate millions of data points daily, and all this will be healthcare data. So it is a very good platform for the upcoming data engineers or data scientists or the people working in the biology field to look into it, because healthcare data will be the next gold in the current generation, in the coming time. Yeah. So how you as a beneficiary will help from the ABDM. So the first is that it will be give you a unified health interface. So every time you go to a different hospital, you have to do different health testing or blood test, or you have to carry the papers every time. But this time it will be not like that. Once you do, the doctors or the physicians will able to stream through different channels and can get your healthcare data, like it happens in the different developed countries. You will have a health ID like an Aadhaar card, uh, which looks like this. You can make it from National Health Authority website. You can interoperability will be there, that it can effectively communicate between
Hi,
different.
Buddhadev. Sorry to interrupt.
Hello.
I I think your slides are not changing. So are you still on seventh slide?
I'm on the eighth slide.
No, it's showing the seventh slide, or it's also not in full screen.
Okay, okay, okay. Is it on the eighth slide now?
No, try sharing your whole screen. I think you are sharing the yeah, now it is on it.
Okay, okay. I'm trying to share the whole screen. Yeah. Can you see my screen now? Hello.
Yes, yes, it is visible. It is
Yeah.
on 8th now. Now it's full screen. Yeah.
Yeah.
Okay.
So, so I am in the eighth slide. So, how EBDM will help you? So, it will give you a unified health interface. Also, give you a health ID. So, health ID will something look like this. You can make it on National Health Authority website or app, and this will actually aggregate all your health data into one platform. When it is fully, so right now it is not fully functional, but we hope that within few years it will be functional. And the digital health services will be much more bloom, like just like the UPI bloomed in last 3 or 4 years, that billions of users are using it. So healthcare data will be the next gold that we are going to churn upon or mine upon. uh, when what will we do about this data? So for this data, we can use this data for the AI universe. So what is the AI universe? It has lot of uh, various terms and terminology. So some say that artificial is the biggest umbrella under which comes the machine learning, then neural networks, deep learning, and generative AI. So everybody is using Chat GPT nowadays and DALI for image generation. So everybody knows what is AI, what is AI, but how to implement the AI for this data? I will come to the next slide, which is so I will talk little bit about the neural networks. So neural networks are very much popular nowadays for doing lot of work, especially the field I work in, the computer vision. So neural networks name also came from a biological identity that is called a neuron. So neuron, as you know, are the basic units of our brain and the spinal system. So what neuron does is it actually, these are the synapses, and the synapses transmit different kind of electrical signals, that is through its channel, through sodium, potassium, and calcium channels. Taking inspirations from that, uh, the neural networks have been built. So suppose this is an input. So these are also differentiated into layers. These layers are called input layers, and then there are hidden layers, and there are output layers. It's a bigger structure, but still I am giving you the cartoonish kind of an image to. So you can see there are a lot of connections and there are a lot of biases. So connection, these are connections and weights are this nothing called mathematical numbers, matrices. If you see the connections, so here we in this cartoon we can find that total weights are 39, and there for each hidden layer there is one biases. So uh, like there are 49 total parameters. Human brains also work similar, or animal or mammalian brain also works similar. That is that you take an input, you pass through a receptor, and those receptors actually, uh, then this is a very complex neural network, biological neural network, that has each and every neuron connected to each other, giving you a comparison how far we have reached if we compare apple to oranges. But still that a human brain has 1 trillion such parameters, and GPT-1 started with 10 to the power 8 parameters, and now GPT-4 that we use in chat GPT-4 has 1.7 trillion parameters. We are very far away from how much our brain is active every day to learn, but we have reached through artificial intelligence up to a certain point that we can say that okay, this could be this. Uh, so, giving you a basics of the digital health and the neural networks and AI, I come to my research focus. So I have given a talk last week in the BioX Club. So the slides could be similar with that, because, but there I think there may be new audience also. So I primarily work on the oral health problem. That is my PhD thesis. And as you know, oral cancers primarily are 30% of the all of the cancers, as stated by the Indian Council of Medical Research. As you see in the before the starting of the movie, that oral cancers are caused due to tobacco, and you should not use tobacco. Apart from cancers, there are lot of other problems like tooth decay, like gums problems, gingivitis, and other oral health problems. So we started as a project to detect all, but after talking to a lot of doctors and physicians, we found out that saving a life is the most important thing when you are working on a healthcare sector. So we focused our work on cancer or early detection of oral cancer. So oral pathology, AI has a lot of advantage like increasing diagnostic precision, enhancing treatment planning, enhancing dental problems early or oral problem early, or have uh, offer predictive insights. So can you hear me? Okay. So is my slide visible, right? Hello. Yeah. Anybody? Hello.
Yeah, it is
Yeah.
visible. AI in
Please
oral
let me.
pathology. Yeah,
Yeah.
yes.
Yeah. 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 So, so in this, what we took an approach of supervised machine learning, supervised deep learning. So supervision is where we put a defined output and we get predictions. All the AI or machine learning things are basically where you put something, we told the machine that this should be the outcome in a perfect scenario, and how much you can predict seeing an unseen scenario. So we give the defined output first, and we implement these models, ML models or deep learning models, and we get the predictions on how much it is correct or how much it is not correct. So it will gives a probability. So our project which I am working on is basically on three things: that collection, so basically on working on photographic images. So we try to collect patient data, photographic images, and their history if possible, if available. So, and then we do annotations by domain expert, which is the most important part in a supervised learning, that a doctor or a physician or a clinical who has expertise in it will annotate and tell the machine that how the machine should predict. Then we come to building an AI models for classification, object detection, or whatever you want to model to build. And our final goal is to make an uh, app or a web platform that can be used in a setup where in a remote setup where doctors or physicians or people cannot reach, where ABHA workers can reach, or like Anganwadi workers can reach, and they will just click on picture and it will tell you, okay, you must have some problem, you should visit your doctor as soon as possible, or it can get connected to a doctor itself. So so by the time a person reaches the hospital in a cancer, he is already a stage 2 or stage 3 cancer, and he may lose his life very early. So that's why we are trying to make an overall web platform that can be used in a very remote areas where the uses of tobacco is too much. So in our workflow, we take images, then we pre-process. So pre-processing is a very important step where we do color grading, histogram equalization of the image, age detection. This can be done through libraries in Python known as OpenCV or something, and anybody can use MATLAB also, whatever he finds good. But Python is what I use, and I find it uh, very easy to use and easy to code. Then we have to do the annotations. As I told you, the annotations are very important when you are doing a supervised machine learning. And in healthcare sector, supervised machine learning is actually very relevant in the real world, because when you are doing an unsupervised machine learning, it can cause error in your predictions, and that can actually affect somebody where false positive or false negative cases can come high. So in annotations, we have different kind of annotation like semantic annotations, instant semantic segmentations, bounding boxes, which I come to the next slide. Then we do model training like object detection, classification, and segmentations. And then we actually see the parameters, how good our model is. That is the model accuracy, recall, and precision, and final prediction based on it. Is it a problematic thing or a non-problematic thing? Is it a cat or a dog? Whatever you are actually classifying or detecting. So image acquisition here is the important part. So because I work primarily on photographic images that are taken from mobile phones, we can take through DSLR camera with high resolution. Mobile photography can be also done, and intraoral camera is something that is a machine that you can put into the mouth and take images from it. There is basic most of the people in the computer vision work on medical or radiographic images. So these are X-ray images, uh, or CT scan images or MRI images. So difference between these are that because this is taken in a hospital setup, and softwares are also installed in most of these X-ray machines nowadays. So uh, the and you can while taking the X-ray or CT scan, you can adjust the contrast and all. So it has a the data is good in these cases, but whereas there may be a lot of ambiguity when you are working with a photographic image, how it took and how much flash is there, how much how it is taken, what is the resolution of the camera. So there is no uniformity when you are working with a photographic image. But yes, in but we have to do this pre-processing step to minimize these noises and extra. So when I'm talking about cancer, so before cancer, there is something called oral lesions that come into picture. So these oral lesions are something that happens before cancer. This is not cancer, but these are early signs of cancer. So a white cottony patches like this is called a leukoplakia, which can turn 20% into a cancer. But something like this as an erythroplakia or erythroleukoplakia can turn up to 60 to 80% to cancer if not treated early. So if we can detect it early, these kind of patches that happen. So this is a tumor, this is an ulcer, traumatic ulcer. If you can detect these classes of problems early, then we can save life. Even one person's life is important when we are talking about healthcare. So uh, so when to label this, we have lot of softwares known as Label Studio or MakeSense.ai, and we label the doctors, and doctors are doctors label this and gives it a class name. Suppose this is an OPMD and this is an OPMD. So these are different kinds of. mm, so this is a polygonal annotations, and this is a bounding box annotations, and these are done by expert doctor only, because I or a engineer or somebody who doesn't have any expertise in it cannot do it. If the annotations are wrong, the predictions will be wrong, and that could be fatal for somebody in a long term scenario. There are a lot of pre-processing. So pre-processing, like we don't want this extra noise when we are side noises, that when we are trying to detect these kind of patches. So we, or this retractor kind of a thing. So we uh, crop this out to get an mask or something like that for detection. So this is a kind of a pre-processing that we do before putting the uh, images into the model. There are a lot of techniques known as image augmentation. Image augmentation is done when you have a very limited amount of data, and this limited amount of data, suppose you have only 100 images and you want to classify with 5 classes. So per class you get only 20 images. So in that, so with less data, the model won't learn better. That's why we do like we just geometrically change the geometrically change the size, rotate, cropping, or do color jittering. There are a lot of augmentations, and you will find in the libraries, the image processing libraries, that you can do to the training images before putting into the model. So, so for the lesion detection, we can do different kind of use different kind of models and different kind of techniques. So we can do an object detection. So if I go to the next slide, so up in this teeth, in this retractors, it, if you can, I can zoom it out. You can see that this on a test set with 0.92% probability, it detected this as a leukoplakia. So this is something called a object detection. So object detection models are like YOLO models or faster RCNN models, and now vision transformer models have come to picture, which are giving better results in some case, so like DETR, etc. Then we can segment this part like we did it here. We segmented the mouth part here. So these segmentations are done using different kind of models like mask RCNN. All are convolution neural network based models and segformers model. And we can also classify. Suppose you want to classify between a normal and a tuberculosis chest. So you can just put the whole image and it will tell you it is a tuberculosis kind of a image or a normal image. So there are also models like ResNet 50 or 100, VGG19, Inception Net, etc. I'm not going into much deeper into the models, but you can find it. If you want to read it, you can find it in Google itself. Uh, and these are some of the results where we have a higher classes of 69 test images of leukoplakia, and we got MAP. MAP is something called how much it area it actually detected, and we got something about 0.5, 0.99% of accuracy, or you can say the MAP value of 0.5%. And for the keratosis is 0.6. So with this much of accuracy for tumors, it is because tumor has a distinct shape and size. With less amount of images, we can detect with 70% probability that this is a tumor. But with the biological data comes a big challenge. That challenge is that here it is not, you are not classifying between a traffic light, it is a red or a green or yellow. It is something, suppose you see this is a whitish one patch, but to the machine it is just a number, right? And a teeth also looks whitish. You may have some in the tongue whitish patch, and there is a lot of chances of misclassification. This is where the color and the shape both in most of the cases are very confusing. Even for the physicians and the clinicians, it's sometimes confusing. For example, oral lichen planus is something which is a whitish patch, and a leukoplakia is a whitish patch. Then how will you detect between that? So a lot of background information, if it is available, can be made into an ensemble model. Those ensemble models will have the patient data, and that will give a better accuracy. That is the patient is what is the age of the patient, what is the tobacco habits of the patient, and you can make an ML model and a deep learning model working together to give a better predictions. Uh, we have also done some classification of the images where you can see this classes like leukoplakia is detected as leukoplakia the highest, whereas there is lot of ambiguity like wrong predictions where ulcers leukoplakia is detected as ulcers. So this is because my data is very complex, which I am working on, and we are trying to uh, improve the prediction results and models. And our data also is very imbalanced. So because leukoplakia is much biologically occurring than erythroplakia, we have very less image of erythroplakia or erythroplakia than leukoplakia. That's why the leukoplakia's detection rate is much higher than other classes of images. We can also do some basic image processing and do a neural network into it, feed a neural network, or we can do and train our model into it. This is called texture analysis because this has a every lesions has some kind of a texture. So these textures are known as Harlick features like homogeneity, contrast, correlation, entropy, or local homogeneity. And based on each and every features, we can segregate them and then we can classify it. But we didn't get much better results. But in a clearer or better data set, we can think about getting a better results. Last but not than least in this thing is an generative AI, which we are talking a lot about. What is generative AI? So generative AI, now diffusion models are in the pictures, but I'm not going into it. So what I have worked on generative AI. So generative AI GAN is a type of a generative AI, which is called a generative adversarial networks. So there are two networks that are, one is generator, which take a noise and generate some fake images. Discriminator said, no, this is not, this is looking like the real samples. So then again, it pushes back to fine tune to generate more fake images. So this war between generator and discriminators uh, continuously go on. And then after having a little bit, after few epochs of running the model, it can give you a fake image which is similar to the real image but not completely identical. So this is, you can see, the basophilic image. That is the real image that I feed into the model, and we got fake image. But so you can see that this is not. This is completely AI generated fake image, but not the real image. Why we need this kind of generative adversarial network in research of biological research is that we have very less data or data is available right now. So uh, suppose you have 100 images, but you need 200 images or 300 images to model to perform better. But in that case, you have to make fake images which are identical to the real images but not real. If it is completely identical to the real images, then it will induce bias into the model that the machine is learning same things over and over. So this is a type of data augmentation where you can generate synthetic data that can help you to train your model for better predictions in healthcare sector. So so I also started doing a different work few months ago. So we did something called erythroblast detection with limited data. So erythroblast, if biological background people will know something that is a RBC which is nucleated. So we call it a NRBC. So this has a nucleus. As you know, the RBC is here. It is the RBC which doesn't have a nucleus. So when some patients who are have blood disorders or they have to remove their spleens. The spleen is an organ, secondary lymphoid organ, which you have to remove. And when you remove this spleen, what happens that this acts as a filter to this NRBCs, and millions of NRBCs actually flow into your bloodstream. And when this are put into an automatic cell counter, so say this is an automatic cell counter that gives you a result of how many cells you have in your blood. It gives a wrong result. It cannot differentiate between NRBC and a WBC, and it gives a wrong result and shows that the person has NRBC in millions, and that actually helps in misdiagnosis, and the doctors or the physicians think that the person may have, at least the pathologists think the person may have cancer because it is uh, which should be 0 to 3 or between 100, it is showing as a millions. So even automation cannot help, sometimes can be very very confusing. So this had to be adjusted by expert pathologists, which most of the rural sectors in India doesn't have. Uh, they rely on the automated cell counter, but a pathologist is not available all the time. So we formed a convolutional neural network. So I'm not going into very deep, but these are the layers of a convolutional neural networks. And you can see the last layers. We have stopped this last two layers, and then we added some classical machine learning classical machine learning classifiers in the last layers, so that it to experiment that is it performing very good with the limited data or not. So limited data is very important when you are talking about a healthcare, because so for supervised learning we are thinking about that uh, first, procurement of the data is hard. Second, the annotation of the data is hard. So we have to work with the limited data to get the better result. So we have used this classifying classifiers rather than the original backbone of the ResNet 50 model. And we got some better result of 97% accuracy, where erythroblast is detected as erythroblast, and lymphocyte and other classes of uh, cells are detected as the cells they are. So this is what how you use computer vision in healthcare. And now I come to the third and my last topic, the AI for biologists. So it is very common myth that are you a PCB student or PCM student? Are you a physics chemistry biology student or a physics chemistry mathematics student? I say, why not both? Why are you not a PCMB student? So it is very social norm that a biologist is weak in maths and engineers don't need bio, right? And that happens due to that our segregation, that a person who is taking biology will not take maths, and math who is taking maths will not take biology, and both streams are running parallel to each other and never convergent. But why not convergent? In developed countries it is convergent and there is a bridge, but we need to bridge this more when we are thinking about digital health or healthcare to work functionally. So so what I say is every creator should interpret and every interpret should create. So what happens is that a biologist actually remains as a biologist. He can't completely generating data like NGS sequencing, like he's doing proteomic analysis or omics analysis and generating a lot of data, but he doesn't know the data. He cannot implement the data. He cannot visualize the data. For that, he may be dependent on any company or any engineer, whereas the engineer is just taking the data and doesn't understand the data. So you should also interpret, and interpreter should create. So that's what I think, and that's how it should be in today's world. So if you are new to this journey of AI, so what I did, because I was also very new to this journey 2 years back when I started this journey, I hardly can code. I hardly can code, and that's why I didn't sat on the placement of IITB. That okay, I don't know that much of coding, and it will be hard for me if I go there. And I also wanted to pursue the research in the digital health. Um, so these are the main four platforms that you can use. First is Python as a language. Python as a language is very easy to interpret. It has a lot of libraries. Everything you want is there in Python right now. So you want to do an image processing, you can do. You want to do deep learning, you can use. You want to visualize, there are libraries like Matplotlib, Seaborn. In deep learning, you have libraries like TensorFlow, PyTorch, which can easily solve all your deep learning issues. Use Google Colab as a coding platform. So a lot of people say that we don't have a laptop or a strong computer to work on. So Google Colab gives you a free uh, platform that you can even use their GPUs up to some extent for initially starting. And so the GPUs, you don't need to buy any GPU or GPU enabled computer for that. You can start your deep learning or machine learning work in Google Colab. So, and to learn how to learn, there are millions of courses also in Hindi, Bengali. I don't know about Bengali, but there are a lot of good courses in Hindi, English, and also courses from Massachusetts Institute of Technology, Harvard, available in YouTube. You can just go through them if you want to learn, if you have time, if you are interested in it, then you can learn from that. And for data, if you have your own data, that's fine. That is very good that if you have your own data, you're working on your own data. Otherwise, there is a platform known as Kaggle. You can just download it from the Kaggle. If you want, so as I said, if you have your own data, then it's very good. Otherwise, there are medical open source data platforms that is known as Medminist. So these are for images. There are also lot of open source data platform for omics like Pride repository, etc., that you can download. And Kaggle also has lot of data available in all kinds of things like tobacco cessation. Government of India is also introducing an open data platform that you can download data from. Uh, Maybe not very much useful, but yeah, you can search your own data there if you are searching something particular. The Medminist is something that has many subsection like path minist where you have pathological images, just minist where you have mm, uh, like chest x-ray images, derma minist where you have skin lesion images, pneumonia minist like pneumonia, and blood minist which I worked on is of different cell images. So you just can download it and start working on it with the previous slide I said can help you in doing that. Um, so the first question is, I don't need, I don't, I'm a biologist and I don't understand what coding is. So coding is something very geek to me and I cannot do that. So you can get, so basic codes you can get in web platform nowadays. So basic codes are available with paper with codes. So paper with code is a very good platform where you get codes of published papers. So paper with code are is a very good platform. Stack Overflow for everyday codes. Everything you need you can just find in the Stack Overflow, and you can just copy the code and try to run it yourself. Yes, you will not get a very proper code that you want, but you have to fine tune that code or adjust the parameter of the codes based on how like what your need is. So if you want to so that much knowledge you should have while coding, that how can I change and change a copied code. And AI for AI codes. So Chat GPT, even the 3.5 free version, or today I heard from somebody that Claude is a platform which is very good for coding. So these LLMs are large language models, which is also an AI, actually codes good. So we can make AI from AI. So AI codes for AI, basically it's a recursion of inception of AI. So ChatGPT is very much uh, capable of doing your work. But yes, everything you need to uh, just you have to understand the code, what I am doing or not. Otherwise everything is available, and you have to understand your data. So that's my time for this. So for the summary, it is the AIML has a very bright future in early detecting of cancers, pre-cancers, and other healthcare problems. And we need to emphasize and need continuous research and development in AIML to improve diagnostic and prognostic outcomes in oral health conditions and other conditions too. Uh, Thank you. This is my LinkedIn ID, and this is my mail ID, and my these are the uh, mail ID of my professors. You can connect with me or them if you want something and want to learn about AI or something. And I also want to thank the BioSDF team and BioX Club and Koita Center for Digital Health for giving me the opportunity for this talk. uh, and biopsy also, and whoever student chapter is a student chapter at Bombay Delhi for giving me the opportunity. And if you have any questions or answers, I am happy to give you the question answers. Yeah. Um, Hello. Yeah. Yeah. Hello.
Thank you, Buddhadev. The session was really, really well explained and very informative. It was helpful to me personally. So thanks for that.
Yeah.
And guys, so you have a great chance to like get some answers. So if you would like to ask any questions, you can ask now.
Any questions? Anything that
Okay, I'll
intrigues you
I'll
as
ask the first question if that's okay. So I wanted to ask, so for these data sources, now you're using DSLR camera, right?
yes, so we procure data from hospitals, first
Hmm.
of all. So you can use anything. So it's means yeah. So mobile. So we want to integrate into a mobile platform. So we try to take it from uh, mobile camera, but sometimes it happens that the noise or there is darkness in the room, then we have to have a flashlight along with it. So DSLR camera is
Mhm.
better. Sometimes we procure the data from them, so it's not in our hand that how we uh, take the photograph. So hospitals provide us the photograph, or the doctors we collaborate actually provide the photographs. Yeah.
Okay, so it's like image based. So I was asking, can we also consider, I mean, maybe you can also consider taking, other kind of signal processing as well, like from medical devices or biomedical system signal
Yeah,
processing.
so basically, so first of all we have to find the objective. Okay, so we can use lot of things. There are something called veloscope, which actually use some near infrared near infrared or something lights that can help to diagnose these lesions
Yeah,
that
yeah, yeah, yeah.
there on.
Mhm.
So,
The
but
ones that we
can
used
you?
during
Is
COVID,
it
right? Like,
practical? Is it practical to do that? If we can take a veloscope or an intraoral camera or something to a place, suppose it is in a 100 kilometers from Nasik or Mumbai, or 200 kilometers. Do they have the rural setup? Will have that kind of an uh, sensor-based device. So it is very so sensor-based device. Then you have a cost of procurement of that device. In that case, it is not practical. So first of things, it is not practical to do that. That's why our aim when we started with the photographic images, we can start with the MRI images, we can start with the radiographic images, for example. But when we started the project, our aim is to make an app that is open source, uh, free for everybody, and simple to simple Anganwadi workers who doesn't know how to operate anything can click an image of the mouth oral cavity, and that mouth oral cavity, our model will tell, okay, you may have some problems. I am not even trying to classify between all the lesions, what is leukoplakia, what is erythroplakia. Even if can say, okay, go and visit a doctor as early as possible, it can save one life, and that one life is the most precious thing that our research can save. So that's our idea. So yeah, yes, for your question, yes, we can do lot of things. So we are planning to integrate NIR, near infrared spectroscopy, to in the future to in this intraoral camera or something. But that I think that will remain in the academy and never go to the uh, the grassroots level where people actually need it. There is a question in the, yeah.
Yeah, yeah. You please take that question, guys. You can also ask the questions in the chat box as well.
So, yeah. So the first question that came, how can I learn? Somebody told great research. Thank you, Vinit Mittal. I am also very much thankful to you that you listened to me and found it helpful. The second question is from Vaishnavi. So how can I start learning AI? A step-by-step guide. What should I learn? So, so you should, if you have lot of time to learn, that you are in a first year or second year of your bachelor's. So basically you start with linear algebra first, mathematics, then you can start with the statistics. So statistics is something that is very much important in AI ML field. So statistics we have to be very strong in, because everything we are predicting, we know that we are doing it with probability. So if you want to make a model from the scratch, you should know what is what. So a linear algebra, statistics is must. Coding, Python is fine for you. If you have one coding language known, it will do all your jobs in this. So Python is fine. So three things: you start learning the mathematics little bit, then statistics thoroughly, and uh, then you come to the coding and you can just start coding itself. It's just you can take help of anything. It doesn't matter. Nobody sees if you are copying from somewhere else or not, but your code should work. So that's what it matters. So I think Python is fine for every biologist right now in today's world. Yeah. And where should you learn is YouTube. I told you there is Coursera courses, so Andrew NG courses that are very easy, uh, that you can learn, start learning from there. Andrew NG's courses. It is detailed, well explained, and it is easy to understand. Who doesn't have a math, even maths in 11 or 12, you can understand from there. But even the YouTube is fine nowadays. YouTube have 100 days of machine learning, 100 days of deep learning courses that can give you a brief idea about what you are going to do. Yeah. But yes, everything you need to see that what I am doing or coding or understanding, can I understand the data or not? What is the predictions and what the data I am feeding? Are you able to understand that or not? So that is what's more important than just running a code valiantly. Yeah. So third question is, I'm wondering about how exactly would you train the model to differentiate between lesion, cancer, tumor patches, while the pictures might not be good quality contrast and might also be different. So yeah, this is a very interesting question. So basically we don't have much data, first of all, and we cannot discard data based on how good it is or how bad it is. If it is not very good, very bad, then we discard that, we delete that data point. But when and the tumor lesions patch with the cancer lesion patch, we try to augment the data. We do pre-processing. We adjust the histogram that actually balance the contrast. There are a lot of histogram equalization techniques. So this pre-processing of the data is very much important. We have to remove the noises from the background that I show you, that showed you that noise is needed to be removed. So so basically what we are doing that from a bad data we try to make a good data as much as possible. Yeah, if the data is very bad, then we delete it, but otherwise, because it is very hard to procure a data, so we cannot afford to lose data, even the picture quality is bad. So and if you want to integrate it into real world scenario, we have to understand that we will get bad pictures itself. Don't People don't have iPhone 13 with them in the rural areas. They will have some Micromax phone, and our model should work there. So that is what is our aim. So we train the model based on how how the data is, and we are getting a good, uh, not a very good result for the oral cancer one, but we are trying to do the best. We are trying to procure more data for the research purpose. Yeah. Uh, okay, there is one course by Biopractiva 2 on course on AI. Yeah, you can look to any course that you want to find comfortable in. It's very like uh, today's world is not confined in a lecture room. Even means even better, mm, means study material is available on the net. If you have time, and if you are really interested in any topic, anything, you will find it on the internet. That is what I find it. And if you need some expert advice, then you can. There are people there in this whole world. They are ready to help, I guess. So nothing is very problematic for anybody. Yeah. Any more questions or anything? I think we are. Uh, so you can connect me through the LinkedIn if you want to. And that's all from my side today. Thank you everyone who have joined, and I'm very much overwhelmed by all of you joining today for my session. Yeah.
Yeah, thank you so much for giving this session and being so accessible to the students. So
Yeah.
that is of great importance in this world, right? Because we need to learn and grow together.
Yeah.
So let's connect, I guess, after the session as well. I have also sent you a LinkedIn request, and guys, like if there are any other researchers in this session right now, then you can also kind of showcase your project or any impactful work that you're working on or have already done. Vinith will be sharing the link in the chat box. You can directly share. And sir, you can also share if you want, you would like to show off your work there, then you can do it to inspire other people as well. So we'll share the link in the chat box.
Okay. Okay. Sure.
Vinith?
Thank you, sir. Dr. Pranta Chakrabarti is my mentor, and thank you that you like, sir. Yeah. Okay. Okay. Thank you, Biorectify, for uh, initiating the session.
Yeah, thank you for taking it forward because without getting help from very generous people like you, we won't be